Hi, good morning. Today's video we are going to evaluate this nice expression of integral sets as I x equal x cosine x minus sine x over x squared plus sine square of x dx. In simple integral, we are using substitution or by parts as a method to solve our integral. But sometimes you need to make some changes before you start evaluating. This is very tricky integral. It's a long-term integral. So we have this integral has three terms. We have x cosine x, we have sine x, we have x squared plus sine square of x. If you are trying to make substitution as a variable change, we have three parts here. So which one we are putting to make it as a substitution? We see the first term, we have x and cosine x, so it doesn't have any combination, doesn't have any connection with these terms to make combination, and make your fraction as simple as possible, or you make your fraction very short term. You will be able to evaluate your integral. So if you are using by parts, we don't have two functions here or two terms. You have to make your by part easily to solve. You have x and cosine x. So which one you put in? If you put x cosine x, you have other terms left. If you split this integral by two parts, by two integral, we will have x cosine x over the bottom one, x squared plus sine square of x, and you have a second integral sine x over this term. Okay, so anyway, you have two functions, but this function x and cosine don't have connection each other to make your term reduced. Okay, so our goal we have to reduce this integral to the short form. Okay, let's start now. Let's put your I integral equal x cosine x minus sine x over x squared plus sine square of x dx. Okay, before we make this one, let's make this dx. Okay, we need to make some changes. Okay, if we are multiplying 1 over x sine x on the top one, and then applying again 1 over x sine x in the bottom one, as we are doing nothing, we just multiplying the first term, the top term, by 1 over x sine x, and then the bottom term, the bottom one by 1 over x sine x. Okay, so we are leaving the top one as is it. We are multiplying the bottom one by this one. Let's see what's given us here. So I equal x cosine x minus sine x. Let's put this one as you see it, 1 over x. Gives me a little bit at the top to make it very clear, 1 over x sine x. Okay, but if you are multiplying the bottom one by x squared by x, it gives you x over sine x, x over sine x. The second term gives you sine square x multiplied by 1 over x sine x, it gives you sine x over x. Sine x over x. So we have two terms on the bottom. Okay. And then we have dx. So if you see here, the bottom you have sine x over x, and then the second term is x over sine x. So this one is the inverse of this one. Okay, so let's put t equal, let's put t equal, let's make more space. Let's make more space here. We have t equal sine x over x. So let's differentiate this one. dt equal this one's, if you differentiate sine x, it gives you cosine x multiplied by x minus the differentiate of x, it gives you 1. 1 over multiplied by sine x over x squared. How we make this one dx? We have the rules. Okay, let's put dx equal x squared over x cosine x minus sine x dt. And we have a rule. Okay, we have f over j as a function. Let's make the differentiation of this one. Let's to see what's given us. This one gives you f prime g minus g prime f over g squared. That's the rule we are applying here to find this one. Okay, now let's log into our integral. This one, if you see it, is the same, right? Let's log in to see x cosine x minus sine x over, let's put this one as a t, 1 over t. This one is 1 over t. Second one, okay, let's put it, we are going to put it later, plus sine x over x. Okay, let's put this one here. We have x squared, and then we have x cosine x minus sine x. Don't forget this term. Okay, this term is dx over ax sine x. Okay, so if you take a look at here, this one, you cancel this one and this one. Okay, so what's left, put this one and then cancel x with 1x, it gives you x over sine x over x sine x plus sine x over x. Okay, dx, right? If you take a look at here, we have this one, x sine x is a t. On the bottom you have x over sine x is 1 over t. The second term, sine x over x, is a t. Okay, don't forget this is not the dx, this is dt, because we are already made the change. Okay, from x to dt, dx or dt as a variable change. So let's log into our integral. X over sine x is a 1 over t. This is 1 over t plus t dt. Okay, your integral will become 1 over t 1 plus t square dt, right? Equal, let's make a calculation. It gives you dt 1 plus t square, right? What is this? This is arctangent. Okay, so our integral become I dt over 1 plus t square, which is arctangent of what? Of t plus constant. Don't forget the constant. And then our integral, we have it in x. We have to make it from, we have to make this change from t to x, because our original function it was x, not t. Okay, arctangent sine x over x plus c as a constant. Very good. Okay, this is our integral. We already evaluated. So thank you for watching. I see you in next video. Bye.